Here we have IIT JEE Main mathematics problem. Okay, let's go to the question. If the equation a times b negative c times x square positive, b times c negative a times x positive, c times a negative b equals to 0 as equal roots, where a positive c equals to 15 and b equals to 36 over 5, then what is the value of a square positive c square? Okay, here we have a quadratic equation, and this quadratic equation has the equal roots. Usually we'll have two roots for a quadratic equation. According to the question, both the roots are equal. And also we can consider the other stuff in the question, that is a positive c equals to 15 and b equals to 36 over 5. So now our aim is to find the value of this expression a square positive c square. Okay, so since we have a and c over here in this expression, let me consider this particular equation, that is a positive c equals to 15. Okay, now to get the value of this expression a square positive c square, what I am going to do is I am going to square both sides of this equation. Okay, let me do it. When I square both sides of this equation, I am getting a square of a binomial on the left side. So I can expand the square of the binomial over here. Then I am getting a square positive 2ac positive b square equals to 15 square is 225. Okay, now in this equation, if I know the value of AC, I can plug in that value and I'll be able to get the value of the expression a square positive b square. So now our aim is to get the value of the product A and C, that is the value of AC. Okay, how can we get the value of AC? Okay, for that we can consider the first piece of information. There is a given quadratic equation as equal roots. That is, we have two roots for the quadratic equation and both the roots are equal. Okay, so to solve this kind of complicated quadratic equation, what we can do is we can use the trial and error method. That is, we can try like x is equal to 1, whether x equals to 1 can be the solution, I mean the root for this equation. If 1 doesn't work, we may try -1. If -1 doesn't work, we may try 2 or -2. In this way we can keep trying until we get the root for this equation. Okay, let me check whether this 1 can be the root of the given quadratic equation. For that I have to plug in this 1 for x over here and here, and also check whether this 1 satisfies this quadratic equation. Okay, let me do it. A times b negative c. When I plug in 1 for x over here, I'm getting 1 square positive b times c negative a, and for this x also I have to plug in 1 positive c times a negative b equals to 0. Okay, so the value of 1 square is just 1. When I multiply this stuff by 1, still I'm getting the same stuff, that is a times b negative c. And when I multiply this stuff by 1, I'm getting the same stuff, that is b times c negative a positive c times a negative b equals to 0. Okay, now I can distribute this a to this b and negative c. Then I'm getting ab negative ac. When I do distribution over here, I'm getting positive bc negative ab. When I do distribution over here, I'm getting positive AC negative BC equals to 0. Okay, positive AB, negative AB will cancel out, and negative AC, positive AC will cancel out, positive BC, negative BC will cancel out. All the terms on the left side are cancelled out. We get 0. On the right side, already we have 0. Okay, when I plug in x equals to 1 into the given equation, we get the result 0 equals to 0. So is it true or false? Clearly it's true, because 0 equals to 0. So the value 1 for x satisfies the given quadratic equation. So for the given quadratic equation, one of the roots is 1. Okay, let me write it. Let me write other stuff. Okay, 1 is one of the roots of the given equation. Let me write it. Okay, since the given quadratic equation has equal roots, what is the other root? The other root is also the same 1. Let me write it. So the other root is also 1, because the equation has equal roots. Now let's find sum of the roots. Let me write it over here. Sum of the roots. Sum of the roots is equal to, that is, we have to add the two roots, 1 positive 1. So sum of the roots we are getting 2. Okay, when the quadratic equation is given in standard form, that is ax square positive bx positive c equals to 0, there is a formula to get sum of the roots. The formula to get sum of the roots is negative b over a. This is a formula. That is, we have to take negative sign and we have to take the coefficient of x, and it has to be divided by the coefficient of x square. In our quadratic equation, the coefficient of x is b times c negative a. Okay, let me take this negative sign over here. The coefficient of x is b times c negative a. It has to be divided by the coefficient of x square. So here the coefficient of x square is a times b negative c. Okay, now we can multiply both sides of this equation by the denominator, a times b negative c. When I do so, I'm getting negative b times c negative a equals to, then this one will be multiplied by this 2, then I'm getting 2 times a times b negative c. Okay, now we can distribute this negative b to the c and negative a, then I'm getting negative bc positive AB, and now we can distribute this 2A to this B, then I'm getting 2AB. When I distribute this 2A to this negative C, I'm getting negative 2AC. Okay, actually my aim is to get the value of this AC. Once I get the value of this AC, as I said earlier, I can square both sides of this equation. I can plug in the value of AC and I'll be able to get the value of this expression, A square positive C square. Okay, now let's solve for AC in this equation, but the term AC is negative in this equation. Our first focus is to make this negative sign as positive. Okay, now let me continue on the next page. So we have negative BC, positive AB equals to 2AB negative 2AC. This is the equation we have on the previous page. Okay, now to make the sign of this AC term as positive, I am adding 2AC to both sides. Let me do it. And when I do so, this negative 2AC, positive 2AC will cancel. Then I'm getting negative BC, positive AB, positive 2AC on the left side. On the right side, we just have 2AB. Okay, now let me subtract AB from both sides, and also let me add BC to both sides. Let me do it. So because I'm trying to solve for this AC. Okay, so here positive AB, negative AB will cancel out, and negative BC, positive BC will cancel out. Then we get 2AC equals to, when I combine 2AB, negative AB, I'm just getting AB, positive BC, 2AC equals to, now what we can factor out from these two terms, we find B in common. So B can be factored. If B is factored out, then we get A positive C inside the parenthesis. Since our aim is to solve for AC, we have to divide both sides by 2 to get of the number 2 multiplied over here. Then this 2 will cancel. Then I'm getting AC equals to B times A positive C over 2. For this B and A positive C, the values are given in the question itself. That is, the value of A positive C is 15 and the value of B is 36 over 5. So we can plug in these values for B and A positive C. Let me plug in 36 over 5 for B over here. Then I'm getting AC equals to 36 over 5 times for this A positive C. We know that its value is 15. So we can plug in 15 for this A positive C over 2. Okay, here 5 goes into 5 one times and 5 goes into 15 3 times, and 2 goes into 2 one times and 2 goes into 36 18 times. Okay, then we get AC equals to, when I multiply this 18 by 3, I am getting 54. Okay, now I got the value of AC, that is AC equals to 54. Okay, now let me consider the stuff we have in the question, that is A positive C equals to 15. Okay, let me square both sides, and I'm getting A positive C the whole square equals to 15 square. Then the expansion of the square of this binomial is A square positive 2AC positive C square equals to 15 square is 225. Okay, now what I'm going to do is I'm going to plug in this 54 for this AC over here. Let me do it on the next page. So we have A square positive 2 times. So for AC, we can plug in 54 positive B square, and on the right side, we have 225. Okay, then we get A square positive. When I multiply this 54 by 2, I'm getting 108 positive B square equals to 225. According to the question, we have to solve for A square positive B square. So we have to get rid of this positive 108. To get rid of this value, I subtract 108 from both sides. Let me do it. So when I do so, this positive 108, negative 108 will cancel out. Then I'm getting A square positive B square on the left side. On the right side, when I subtract this 108 from this 225, I'm getting 117. Okay, now I got the value of the expression A square positive B square. Its value is 117.